Students, so we have almost reached the end of the semester. So do you remember you have joined in the month of October and classes started on October 5th, right? See how quickly the months have we have completed, 3 months and reached the fourth month. We entered into the new year. January 1st also over, and now we have reached the end of the semester and the end of the third unit, that is quantum mechanics. Okay, so this class will be the last class of quantum mechanics, students. Okay, so today's topic, you please put the side heading as postulates of quantum mechanics. Mark it as a very important question, students. There are just 5 postulates, 5 simple points. Within 5 minutes you can easily read and learn. Okay, so kindly put the side heading postulates of quantum mechanics. Okay, now underline the side heading, students. Postulate number 1. The first postulate of quantum mechanics says that, okay, write down. The first postulate says that state of any system is described by wave function, which is denoted by psi of x, y, z, which has the complete information about the system. What is that, students? Write down. The state of a system is described by the wave function, which represents amplitude of the wave and is denoted by the letter psi of x, y, z, which contains all the information of the system. Okay, so first postulate is nothing but psi explains the state of any system. Okay, next postulate number 2. Postulate number 2. Any physical property of the system represented by the letter A is explained or characterized by an operator which is generally denoted as A cap. Students, while learning the derivation of Schrodinger wave equation, we have come across few operators like Laplacian operator, Hamiltonian operator. Do you remember, students? Okay, so here second postulate says that each physical property of a system represented by the letter capital A is characterized by an operator A cap. Okay, reading out once again, students, for the sake of you. Each physical property of a system A is characterized by an operator A cap in quantum mechanics. Okay, that is the second postulate. Next, third postulate number 3, students. The values obtained by measuring the physical property which is represented by letter A, the possible values obtained by measuring any physical property represented by the letter A, they are given by the specific value called as eigenvalue, students. Okay, so write down, of any physical property A are given by eigenvalues, E-I-G-E-N. Eigenvalue, we represent it by AI. See, I have written in the brackets, given by the eigenvalues in the brackets AI of the equation. Below the sentence, write down, students. Don't write it besides. So here you write down A cap psi I is equal to A cap psi I is equal to AI into psi I. Okay? What is that, students? The values obtained by measuring any physical property represented by the letter A of any system is given by, possible values are given by eigenvalues, and eigenvalue we denote it by AI of the equation A cap psi I is equal to AI psi I. Understood? So, below that write down, students, where A cap is eigen operator. We have seen each physical property A is characterized by an operator. So A cap we call it as eigen operator. AI we call it as eigenvalue, and psi I is called as eigen function. Okay, E-I-G-E-N, students, we pronounce it as eigen. A cap is the operator, eigen operator. Psi I is the eigen function, and AI is the eigen value. Okay, so that is the third postulate. Fine. So possible values obtained by measuring any physical property are given by eigenvalues. Okay, students, that is the third postulate. Next, fourth postulate. Put the side heading. Postulate number 4. Postulate number 4. Third postulate, we have seen possible values are given by eigenvalues, right? Now, fourth postulate says that the average value of any physical property, that is A, characterized by the operator A cap, it has an equation. What is that, students? Try to follow the postulate. The average value of any physical property. So we have seen what A is and what A cap is, right? By this time you might have understood. A is nothing but physical property of the system. A cap is the operator by which the physical property is being characterized. Okay. So now, suppose if you take the average values of any physical property, so how to put it in the form of an equation? So fourth postulate of quantum mechanics gives us the equation. Write down. So average value, that is A, is equal to integral. This is called as, we call it as integral, students. Okay, differentiation we have seen now, that is small letter d. This is a integration. So integral psi star A cap psi d tau, TAU, students. This is a TAU, okay, tau, by integral psi star psi d tau. Okay, so average value of the physical property, when we measure it, we can calculate using this equation. So how? Integral psi star A cap psi d tau by integral psi star psi d tau. Okay, so in the brackets besides this equation, write down what is this psi star. Psi you know, right? Wave function. So psi star is complex conjugate of psi. These are all mathematical terms, students. Okay. Psi star is nothing but complex conjugate of psi. What is the meaning? Complex conjugate of psi means equal but opposite in sign. Okay. Below also I have written, see, that is equal but opposite in sign. For example, 3 plus 4i. Its complex conjugate 3 minus 4i. Okay. So don't worry about this equation. Just try to practice this and remember. Okay. So we don't need the solutions or derivations of these equations. Okay. So the average values of any physical property we can get using this equation. Okay, students. So this also you did not write in the exam. Just for your information I am giving you. Psi star means it's the complex conjugate of psi, which is nothing but which has almost equal value but simple opposite sign. Okay, that is the fourth postulate. Next postulate number 5. Postulate number 5. Kindly put the side heading postulate number 5. So we have seen in the first postulate that the state of any system is described by the wave function which contains all the information. Okay. Now what this postulate 5 says? Psi, which represents the state of a system, psi which represents the state of a system changes with time dependent Schrodinger wave equation. Students, the Schrodinger wave equation which we have learned in the first class, that is time independent Schrodinger wave equation. There is one more Schrodinger wave equation which is time dependent. Okay, but in your syllabus that is not there. That's why I did not teach you. Okay, so here size changes with time according to time dependent Schrodinger wave equation. Have you written it, students? Once again, psi which represents state of a system changes with time according to time dependent Schrodinger wave equation. So below I have given time dependent Schrodinger wave equation. Right now, IH by 2 pi into dou psi of xyz. Schrodinger wave equation we stopped with psi of xyz. Xyz means you know 3-dimensional. But here one more letter is being added, comma t. T means time. Okay, because it is time dependent Schrodinger wave equation. By dou t is equal to h cap psi. H cap Hamiltonian operator. Psi of xyz t. Okay, so here I is nothing but square root of minus 1, students. Okay, square root of minus 1 is taken as I. Okay, so you need not write that also, just simply write this equation. Okay, so these are the 5 postulates of quantum mechanics, students, which is a very important question. Don't skip this question along with the I told you now, black body radiation, this Heisenberg uncertainty principle, which are the assignment topics. Along with those topics, you should study postulates of quantum mechanics also, because we don't know which question will be asked from quantum mechanics, as almost all the topics are important. Okay, students, draw a line till here. This is the answer for postulates of quantum mechanics. Next topic, students, put the side heading energy levels. This is also a short answer question. Students, put the side heading energy levels. So we have learned Schrodinger wave equation for a particle in one-dimensional box, from which we can calculate the energy of the particle. Okay, do you remember that equation, students? What is that? E is equal to n square h square by 8 ma square. So write down energy for a particle in, write down, students, energy for a particle in one-dimensional box is given by, energy for a particle in one-dimensional box is given by, below write down the equation. E is equal to n square h square by 8 ma square, where n is an integer, m is mass of the particle, a is length of the box, x is equal to 0 to x is equal to a. Okay, written. Now, as this n is an integer which can have the values 1, 2, 3, 4 and so on, energy can have distinct values. Okay, so when we substitute the values of n in this energy equation, discrete energy levels can be obtained. Okay, so below I have given example like n is equal to 1, n is equal to 2, n is equal to 3, like that. Okay, write down. Suppose when n is equal to 1, if we substitute the value of n as 1, this equation changes as E is equal to h square by 8 ma square. Okay, the first energy level. Next, n is equal to 2. Substituting n value as 2 in this equation, we get E2 is equal to 2 square means 4h square by 8 ma square. Next, n is equal to 3. E3 is equal to, substituting n value 3 in this expression, E3 is equal to 3 square means 9h square by 8 ma square. So suppose like this, when we substitute different values of n, we get different energy levels like this. So we will see what we can infer from these energy levels. Have you written, students? Okay. So as the value of n increases, what happens, students? The separation between the energy levels increases. Okay. As n value increases, the separation between the different energy levels also increases. Now this separation not only depends on n, okay, it also depends on length of the box. In case if the length of the box is increasing, students, so x is equal to 0 to a we have taken. If this length, that is a value, increases, what happens? The space available for the particle to move inside the box increases. And what happens? The levels come closer. The length is increasing and the levels come closer. So, where is this length in the expression? In the denominator. As the value of a is being increased, left side e value will be decreasing. Okay. So, now if this length goes on increasing, if it is becoming larger and larger, what happens? This left side e value is there, energy value in the expression. That becomes minimum, but energy of the particle never becomes 0, students. Why? What is the reason? Because n value, the minimum value of n is 1 but not 0. Okay. So these 2 points were supposed to mention about the energy level, students. What are the 2 points? As n value increases, separation between the energy levels increases. Now this separation not only depends on n but also depends on length of the box, which is taken as a. So when this length is being increased, the levels come closer and closer. That means E value, that is energy value, will be decreasing. So when this length has become too large, E value becomes minimum but it never comes to 0. Why? Because n value starts from n is never 0. Therefore, it is the last sentence, students. Due to this, E values becomes smaller and smaller, and if the length of the box becomes large, energy becomes minimum but doesn't become 0 as minimum value of n is 1. Okay. So, draw a line till here. This is the answer for energy levels, students. This is also a short answer question. Okay. So, students, the last topic of this unit, put the side heading wave function. Put the side heading wave function. Okay, underline it. So students, this Schrodinger wave equation which we have derived, this has got a name and it can be called as second order differential equation. What is the meaning of it? Second order differential equation means it can have many solutions, but many of these solutions, they do not have a certain importance or significance. Okay, so that is your first sentence. Please write down. Schrodinger wave equation is a second order differential equation, which means that many of these solutions, they have no significance. Then which solution will have significance, students? So that is the second sentence. See, the solutions will have the importance when certain definite values of total energy are substituted in this Schrodinger wave equation. Okay, then only such solutions will have significance. Okay, that is your second point. Write down. The solutions will have significance only for certain definite values of total energy represented by the letter capital E. Okay, and these definite values of energy, they are called as eigenvalues. E-I-G-E-N. Underline. Eigenvalues. Okay, now when these certain, when these definite values of energy, that is eigenvalues, are substituted in Schrödinger wave equation, it gives us the solution, and this solution gives us the values of wave function, which can also be called as eigenfunction. Once again, students, this Schrödinger wave equation has many solutions, but most of them, they do not have a significance. But which solutions will have significance? Where there are certain definite values of total energy. These are called as eigenvalues. When these eigenvalues are substituted in Schrödinger wave equation, the solution gives us the value of a wave function, which is represented by psi, and this can also be called as eigenfunction. Okay, that is the third point from here right up. So when these values of E are substituted in Schrödinger wave equation, then the solution gives the values of a wave function, psi, or eigenfunction. Okay, so underline, students. Now, so when we are calculating the energy of the electron in the nth level using Schrödinger wave equation, there involve three constants by name N, L, and M. Okay, so write down this point. While solving Schrödinger wave equation, for energy of an electron which is present in the nth level, three constants N, L, M are involved, and these three constants are related to one another, students. Okay, so that is this point. Three constants are involved and they are related to one another as follows. I will tell you how they are interrelated with one another. So write down how they are interrelated, students, below point A. First point. The values of N plus L and 2L plus 1 are whole numbers. Okay, the first point, values of N plus L and 2L plus 1 are whole numbers. That is point A. Next, point B. Point B, L is less than equal to N minus 1. Next, third point, the values of M, they vary from VARY, students, vary from minus L to plus L. Next, fourth point, the value of N must be integral. Fourth point, the value of N must be integral, and L may have, while L may have integral values from, fourth point, students, the value of N must be integral, while L may have integral values from 0 to N minus 1. Okay, so like this, the three constants N, L, and M are related with one another. Okay, students. So below write down the last sentence. These three constants N, L, M, they signify the three quantum numbers of an electron. Okay, the three constants N, L, M, they signify the three quantum numbers of the electron. Okay, so these are the points which you write under wave function, students. And one more sentence, students, below put the side heading, significance significance. So what you will write under significance? Generally, we all know that psi represents amplitude of the wave, which is called as wave function. Okay, write down. Psi represents amplitude of the wave which has no physical significance. Which has no physical significance, but psi square has significance. This we have learned while learning probability density, students. Dual nature of electromagnetic radiation, probability of finding the electron. There we have learned that psi square is the measure of probability of finding the electron. Do you remember? If you turn back the pages and check probability density, there we have seen the points how psi square is the measure of probability of finding the electron. Okay, so the same you will write here. Psi represents amplitude of the wave, whereas psi square is the measure of probability of finding an electron. Okay, suppose if psi square is also 0, then probability of finding the electron will be negligible. Okay, students, fine. So this is all about this answer, wave function and its significance. So finally, we could complete this third unit, that is quantum mechanics, students, and all the assignment topics, they are being uploaded on my channel. You please write those topics in your notebook and try to start preparing for your end semester exam, students. Okay, so all the best for your exams. Kindly don't waste your time, students. Now it is not the time to relax. It's the time to prepare for your exams, because now I know that you will start from gaseous state first page, right? So this will be a very big burden on you. So start reading from now itself without wasting any time. Try to spend 1 hour for my physical chemistry portion. Okay, students, thank you, take care, stay safe, and bye-bye.